Hello friends. So today I'll discuss about the Eigen values and Eigen vectors. What is about the Eigen values and what is about the Eigen vectors and what is its applications? Eigen values as the most applications in engineering sector. Eigen values, the engineer applications be used. Eigenvalue problems are among the most important problems in concerning with the matrices. And the students should follow our present discussion with particular attention. We first define the basic concepts of and explain them in terms of typical examples. So, our practical applications, when we can follow and just we can use a given matrix, let A is equal to one matrix we have to consider, let A. N cross N matrix of vector equations. N cross N matrix. This is a matrix and which consider as N cross N matrix. N cross N matrix. And just define a vector equation. We can define a vector equation. Define a vector equation. What is this vector equation? And that is Ax is equal to lambda x. And just naming that equation is 1. What is x and what is lambda? X is an unknown vector and lambda is an unknown scalar. X, unknown vector. And lambda, unknown eigenvalues. The two terms you remember, x is equal to lambda x, for x is unknown vector and lambda is unknown eigenvalues. Clearly, the zero vector, when we substitute x is equal to 0. So here you have to discuss about the x is unknown vector and lambda is the unknown eigenvalues. When x we substitute 0, what happens? That is belongs to a zero vector. When we substitute x in equation 1, then 0 is equal to 0. That is zero vector. So this is no practical interest. There is no solution. This is no practical interest. There is no solutions. So for evaluating the eigenvalues of lambda, we must take the x is not equal to 0. Then to evaluate the eigenvalues. So it is the eigenvalues or characteristics values also we can say that. The corresponding of all eigenvalues, the set of all eigenvalues means lambda, if the eigenvalues which contains lambda 1, lambda 2, lambda 3, set of all eigenvalues is called as the spectrum. This set of all eigenvalues, set of all Eigen values called as spectrum. Set of all Eigen values is called as the spectrum also. And the highest or greatest Eigen values is called the spectral radius. The largest of the absolute values of Eigen vectors. Eigen values is called spectral radius. Largest values of lambda by Eigen value is called as the spectral radius. So what is the spectral radius? Just we can represent here the largest values of lambda is called as a spectral radius. And then we will discuss about some problem determining the Eigen values and Eigen vectors of the matrix is called an Eigen value problem. The problem determining the Eigen values and Eigen vectors of a matrix called as the Eigen value problem. Eigen values problems. The problem of determining the Eigen values determine the Eigen values and Eigen value problems. Determine Eigen values and Eigen vectors. That is called Eigen value problems. Or the set of all Eigen vectors corresponding to Eigen value A, including with 0, is called the Eigen space. Just to consider one example. How to find the Eigen values and Eigen vectors? How to find Eigen values and Eigen vectors? The determination of Eigen values of Eigen vectors. First of all, consider any one of the matrix A. -5 to 2 -2. That is 2 cross 2 matrix is there. For calculation of Eigen values, we have to consider Ax is equal to lambda x. So we consider Ax. X is the variable of 2. Is equal to lambda x. Or determinant of A minus lambda I into 0. That is Ax minus lambda x is equal to 0, and that is A minus of lambda into y determinant into x equal to 0. Then we solve A minus lambda I determinant equal to 0, and to evaluate the values of lambda, let determinant of A minus lambda I 0. Then values of lambda is called Eigen values. The values of lambda is called Eigen values. Just one example I have taken here. A minus lambda I. A means already given 5 minus 5 2 2 minus 2 minus lambda I minus lambda into identity matrix 1 0 0 1, which is equal to 0. Just you can multiply this lambda value here, minus 5 2 2 minus 2, and this is lambda 0 0 lambda. Then minus an evaluated determinant, minus 5 minus lambda 2 2 minus 2 minus lambda determinant, that is equal to 0. Then we can evaluate the value of lambda. 5 plus lambda wholes into 2 plus lambda minus 4 equal to 0. Then what is the values of lambda? We can simplify this equation and evaluating this lambda value, that equals lambda square plus 7 lambda plus 6 equal to 0. Lambda square plus 7 lambda plus 6 equal to 0. Then what are the values of lambda? Lambda is equal to minus 1 and minus 4. So lambda is equal to minus 1 and minus 4, and these called the Eigen values. These are called Eigen values. Then corresponding Eigen vector you need to evaluate here. What is the corresponding Eigen vectors? There are, when lambda is equal to minus 1, then Eigen vectors. Then corresponding Eigen vector. Eigen vectors. What are the corresponding Eigen vectors? A minus lambda is that value minus 5 minus lambda 2 minus 2 minus lambda whole into x1 x2 is equal to 0. Then we can just compare, multiply this value, put the value of lambda is equal to minus 1, then minus 4, 2, 2, 1, minus 1 into x1 and x2. That is equal to 0. And the value corresponding vector is just multiply first row and first column, and multiply this row is multiply with this column. This column. Then what is this result? Minus 4x1 plus 2x2 equal to 0. Then we can say that 4x1 is equal to 2x2. Then x1 by 2 is equal to x2 by 4. And that is also called that x1 by 1 is equal to x2 by 2. So the value of x1 is 1 and x2 is 2. Hence the vector, corresponding vector lambda is equal to -1. Hence corresponding vector lambda is equal to -1 is now x1, x2 is the vector, x1 is 1 and 2. Similarly, we can use also another case, that is a minus 1 eigenvector corresponding to lambda is equal to -2, lambda is equal to -6. That is -6, not -4. Hence, when lambda is equal to -6, the corresponding eigenvector corresponding eigenvector -5 माइनस लैम्डा, लैम्डा की जगह में हम डाल देंगे -6, तो -5 + 6 2 2 -2 + 6 into x1 x2 is equal to 0. That is 1 2 2 1. x1 x2 is equal to 0. Then x1 plus 2x2 is equal to 0. Then x1 is equal to minus of 2x2. So x1 by 2 x1 by 2 is equal to x2 by -1. So what are the vectors becomes? Now vectors becomes eigenvectors. What are the eigenvectors? Lambda is equal to -6. Then this vectors becomes 2 -1. So these are the eigenvectors. Okay, so we have to evaluate the eigenvectors of this function. Okay, so thank you to all.